Ciao friends! In this Unplugged video, I will try to answer to a question that I received from Alberto. Alberto sent me an email the other day asking, Marco, when I open a large Power BI file, I wait a lot of time, more than 1 minute, just to see the content of the file. Why is this happening? So I'm going to try to describe what happens when you open a Power BI file, trying to examine a relatively large file in Power BI, and we will learn what happens under the cover. I think that we will not learn something new in terms of optimization because there is not much we can do, but at least you will be aware of what is happening. And I can anticipate that the only way to reduce the time, the loading time, is to reduce the size of the file for the reasons that I will describe you in a minute. So let's go to the demo machine here. I have here one file, this Vertipack. Let's see if I can show this. Is visible? Yes, okay. So we have, this is the file, the PBIX file, and this is the size. The size is 1 gigabyte and 467 megabytes. The amount of rows we have in a single fact table here is around 4 billion rows. So let's see what happens when I open this file. You see that I have here the task manager open. At the moment, we don't have a Power BI open here. And the only process that is consuming resources is OBS Studio that I'm using to manage this recording. And if I look at the performance, however, even though I have OBS Studio running, I still have 70% of the CPU available, and I have more or less 27 gigabytes of RAM available because I have 32 gigabytes of RAM. This is a single socket CPU with an i7 with 8 virtual cores. There are 4 physical cores and 8 with a virtualization. And you can see the number here at the bottom here, sockets, cores, logical processor, and so on. But let's say that we can just take a look at this window. And let's see what happens when I open the window. We will spend 1 minute just looking at what happens here. And then I will try to describe using the whiteboard why we will see these numbers. So you see that now I have the Power BI window open. This Power BI desktop appear here, but here we have a list of processes that are running managed by Power BI desktop. And you can see that there is one process, analysis services, that is growing in memory, is slowly growing in memory, allocating more RAM here. You see that we have 6, 7, 8 gigabytes and running. Now, probably I didn't pay attention. At the very beginning, we had a moment where the disk was at 100%. But this machine I'm using is using solid-state disk, so it's relatively quick to read the content of this 1.5 gigabytes and to do something. Do what? Well, we will see later, but you see that now we're still waiting. But what happens is just now we see other processes running and we see the user interface of Power BI. And you see that analysis services is here, is not consuming CPU. It didn't consume CPU for a moment. And now we have, let's reply to this dialog box here. Let's see if I can say yes, not yet. Okay, so we can go back here. And you can see that we're still not displaying anything. We're still waiting that the query is running, and it is still analysis services running 80–60% of CPU. RAM is not increasing. We have seen the RAM went up and then went down. Now that we see the result here, we see that Power BI Desktop is no longer the more expensive process in our machine. And if I go in performance and I see what happens, you see that for this entire part of the CPU history, we had all the cores running 100%, and only when I have seen the user interface, the CPU dropped, and I waited other time before something was visible. So clearly, we cannot understand much more just looking at this. There will be other techniques to analyze the files that are open, what is happening in memory. But I think that the best way to explain what is happening is to move to the whiteboard and try to see step by step what are the actions executed by Power BI, and to explain why we have seen the CPU and or the RAM going up. So let's go to my whiteboard here, and let's try to describe what happened. So first of all, at the beginning, we had a Power BI file. So I draw here my PBIX. This Power BI file was 1.5 gigabytes. Now, this is CB, okay. Now I open the file. What happens when I open the file? We have a process. The process is Power BI Desktop, PBI Desktop, that opens this file. So it's an open. This is the first operation here. When I open this file, you have to know that the PBIX file is just an extension for a zip file. And this zip file, which is technically Office, I don't remember the format. It's a standard format that is used for documents embedded into a single compressed file. This file contains several other files. So it's a zipped file that contains several JSON files, several other XML files, JSON files. There are many, many files with different formats. But one of those files is the backup of analysis services that contains the model and the data for your Power BI model. So we can ignore, so let's say that this is a list of many files, right? And all these files are 1 kilobyte, 2 kilobytes, something like that. But if this was 1.5 gigabytes, there is a backup file here. It doesn't have this name, but just to identify this as a backup file, that is very, very similar, 1.5 gigabytes, something like that. This file has to be opened by analysis services. But before doing that, the original zip file is expanded into a folder in my temporary, in a temporary folder in your computer. So if you had 1.5 gigabytes, there is an unzip happening here. Imagine unzip here, unzip. My writing style is not good. But this unzip creates a copy of the data uncompressed. Now, uncompressed means that because this backup file is already compressed, the size is usually very close for a large file, because the backup is usually 99% of the entire PBIX file. However, this copy can take a while. Now, for 1.5 gigabytes on a solid-state disk, it is just a few seconds. But if I had a 20 gigabytes file, I mean, if you have enough RAM, you could open a PBIX file with 20 gigabytes. It could have required 10, 15, 20 seconds or more just to copy the data in this first step. Now that we have this data uncompressed in a temporary folder, what happens? Power BI Desktop start analysis services. Analysis services is the process that has the engine for Vertipack, DAX, all this stuff. And analysis services receives this file and perform what is called a restore operation, restore. This backup file is like another zip file that has to be expanded in a temporary folder. So once again, we have another folder. So let's say that this was temp 1. Now we have temp 2, which has just this file uncompressed. And what happens here? Well, here we have something like, not exactly this, but the model.bin file, just the description of the model in the tabular object model. Oh, I have to move this here. Sorry, I have to go here this way, so it's visible, so I don't hide the content. Okay, good. So we have the temp2 folder here, which is this one. Let me highlight this. We're looking at this one, temp2. So in the temp2 folder, I have the model.bin, then I have one folder for every table. Every table has a list of files here, one file for each column, plus indexes, plus many other things. Some of these files are compressed, some of these files are not. For example, the content of the data for each column is compressed, the content of the dictionary is not compressed. What does it mean? If the size of the backup file was 1.5 gigabytes, the content of this temporary folder is larger, I don't know how much, but if you are curious, you can open DAX Studio, and let's go to the demo machine 1 second. So I open DAX Studio here. I connected DAX Studio to this model, and with view metrics, I can try to analyze the content of this model. It takes a few seconds because this requires running a few queries to the model. And here we go. We have the total amount is 10 gigabytes. So remember, we had only 1.5 gigabytes in the PBIX file. The size reported here is close to the size we have for the model in memory, which usually correspond more or less to the size of the temporary folder that has the expanded backup of the original analysis services backup. Yeah. So actually, it's interesting here to see that most of the data, this is the table that has 4 billion rows, most of the data here is not in the dictionary, is in the columns, but clearly the compression algorithm that we have for the backup is compressing more than the original compression we have in the columns, which is good. Probably we have some columns stored with a value encoding, probably, I don't know. So these are details we can ignore. But we have now the number, so I can go back to the whiteboard, and we can say, okay, if I had 1.5 gigabytes here, I know that now this is 10 gigabytes, more or less, right? Now, moving from temp 1 to temp 2 required this little bit of RAM, CPU. So we have seen the CPU consumed here. So this was, let's say, this was just I/O, right? Or, sorry, let's fix this, I/O drive. What happens here, in order to do this step, we have, again, I/O plus CPU, because uncompressed data requires a little bit of CPU, but this is not enough. You have seen that once we had our analysis services process, at a certain point, it was around 25 gigabytes and then dropped to 10 gigabytes. Why? Because during the restore, we have additional memory consumption that then is deallocated and released to the operating system. So at the end of the day, we know that more or less we have for analysis services, we can go back to Task Manager. So let's see if I can see the Task Manager here. And currently, the analysis services process, which is hidden somewhere now. So let's see if I can find it here. So MSMD SRE, okay. So let's see if I can find it. Here we go. So this is running in something more than 12 gigabytes, so close to 13 gigabytes of RAM used by analysis services. But at a certain point, the RAM was higher than that, and then dropped. So what happened at that point? As I said, the restore could be an operation that requires a little bit more memory than the memory just required for the model. Once the restore operation was completed, then we still waited other time. But at that point, at least we have seen the user interface of Power BI Desktop appearing on the screen. So let's see if I can resize the screen a little bit and what happened at this point. So Power BI Desktop, so I can move my window at the top so I have more space here. What happened at this point is that Power BI Desktop again created the window. So which color can I use now? I don't know. Let's use the green color again. So we have seen the window with the report. And the report was just a matrix. If I remember, it was a matrix. And this matrix is a visual. And this visual generated, so this was the matrix displaying data from the model. And in order to populate this matrix, DAX query was sent to analysis services. And this DAX query returned a relatively small set of data to populate the table, but executing the first query over the model we just restored required an additional effort in terms of CPU and a little bit of RAM by analysis services, but mainly CPU. Why that? Because for the first time, the storage engine here, so let's say that we have, I finished the colors here, so let's highlight this area here. So we have, this is usually the formula engine is something we draw in yellow. And let's see if I can find another color for the highlighter. Come on, this one. And here we have this area here is what we call the storage engine. So this is the storage engine. And the storage engine, for the first time, the storage engine sent queries over the RAM. But guess what? We expanded the model in a temporary folder, but this model was around 10 gigabytes, but this model had to be loaded in RAM. Indeed, if you remember, we had around 12 gigabytes of RAM used by analysis services. So imagine that this entire model has been loaded in RAM. And the storage engine here, the storage engine I'm highlighting here, has to scan many of the columns to retrieve data that I was asking in that report. Actually, we are not, so let me remove my face here. So this is what is happening here. So the RAM has to be scanned completely, right here, 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 only for the columns that we are using. So probably we didn't have to scan 12 gigabytes of RAM, but most of this RAM was probably used by the query that I sent. I don't remember exactly, but it was an expensive query that I had in that report. So this is what we had. So let's see if I can show this in a way that is visible without me covering it. Let's try this way. Okay. So let's see if I can recap. So we said that we have seen the analysis services was the process consuming RAM and CPU. And the same data had to be copied several times. So you can imagine that when we have a large model, you can see that these multiple steps for opening the file, copying the file, unzipping the file, copying the small files in a temporary folder, then loading these files in memory, it requires time. And it's important, just for that initial step, it's important to have a fast drive. A solid state disk in your PC is very important to reduce the loading time for a Power BI file. Of course, if you have a model that is only 10 megabytes, is not that expensive, but with larger models, that could be expensive. And why, when we have, for example, when we publish this model on Power BI, the service, it seems faster. But why? Well, simply because for a number of reasons, especially when you have a large model, at least one part of this process could be skipped. For example, large models are not stored, if I remember well, they are stored just with the model, so you don't have the step, for example. This is the difference between small and large sites that you have. You have two ways of storing the data in a workspace. One is the small files format, which is the default one for the Power BI file, Power BI PBIX files. And one is the large model format, which is an option when you create a premium workspace, for example, but it's something that is triggered automatically when you have an incremental refresh enabled on the workspace. So when you have these conditions, this step doesn't happen, and so you already have one less step to execute. But of course, the data has to be retrieved from the storage and loaded in memory. So the step that you cannot skip when the model is not in memory the first time you open it is this one. This one is the step that could require time because you have to populate the RAM with the data coming from the storage. Now, if you have a model that is used by many users continuously, more or less, especially in Power BI, this is always in RAM. But this explains why publishing the model on Power BI could be faster for certain large models. And publishing it on analysis services guarantees that you always have the data in RAM, so you don't have to do this additional step. This one doesn't happen, so we skip this, we skip this. We always had this in RAM. With Azure Analysis Services or Analysis Services on premises, this is guaranteed. When you have Power BI, this is not guaranteed, even though for the models that are usually used by many users, we tend to have these models always in memory. So is the service that optimizes the loading for us. So we have seen that waiting time when you open up a Power BI file is something that is related to the size of the model. Of course, even though you have a small model, sometimes the opening time requires time. Seconds maybe, because Power BI Desktop has to execute several processes and has to coordinate the communication between several processes. I hope that Microsoft will find a way to optimize that because sometimes I open a new file and I wait for more than 10 seconds, and I mean, it's too much from my point of view. But when this waiting time is too long, now you know what you have to look at, and if you can afford, if you realize that you have too much waiting time for the disk, probably you need a faster drive. Solid state disk is a good option. And if you just consume CPU, you can just get a faster machine with more cores. I hope you enjoyed this Unplugged, and as usual, enjoy DAX.